Makeup Activity by Esteban Moreno Vergara, 8A. First part, Mark and Recapture method. The Mark and Recapture method is based for know how many type of individuals will be in a determined place. For making this method, we have to base on the 5 steps given for make the method that are: first, mark randomly; second, release; 3, wait a few days and come back again; 4, resample; 5, taking account the market and those who haven't been market. After that, we have to make the equation that is n equals m times n divided x, where the first n is estimated population, the m is total first market sample, the second n total recapture on the second sample, and the x animals that have been seen again. So my market recapture project was made about beetles. I do about the rhinoceros beetle, and in my zone was a park. So after analyzing my results, I want to know why the population of this beetle wasn't too much at this park. After searching about the beetle, I looked at he didn't live in the environment that the park can give to him. So I say, how will be there? How will be he there if this environment wasn't for him? After analyzing, I saw that close to the park that I make the thing, it was a wetland when maybe he was living. So maybe he was flying at the night looking for a couple, as they do every day and in the night, and maybe something happened to him and he fall down to the in the park, and that's why I find him at that park. Or maybe someone else put him in that place and the person tried leave him or took him from another place that can give the conditions to him. So what I conclude is that my most serious hypothesis is that he fell down when he was flying, and that it was an accidental dispersion, and that it had no population, a big population there, because this animal doesn't live there. But if I make it in a place that they live, mostly we can find a bigger population of the Bell's rhinoceros. Second part, dispersion method. Dispersion method means and is for know the relative spacing of each individual to other. Know how many types, for example, plants are in a specific place, and if they are really close to each other or they are really a go of each other. So making this, we can know which dispersion those the yellow flowers have. It can be a random, uniform, or clumped dispersion. So what I do for know which dispersion had this part of these yellow flowers are that I make two quadrants, sorry, one in a side and other one in the other side of the park, for now if there was more yellow flowers on one side of the park, or and in the other one weren't the same. So for now this I make two quadrants. The first one was about 1.50 meters long times 1.50 meters weight, and with 9 subquadrants, each one of 50 centimeters times 50 centimeters. The first one, we got these results for each subquadrant. Each subquadrant got a value of flowers. The first one got 1 flower, the second one 2 flowers, the third one 1 flower, the fourth one 3 flowers, the fifth one 0 flowers, the sixth one 1 flower, the seventh one 1 flower, the eighth one 2 flowers, and the ninth one 1 flower. After looking this, I made the I take out the mean and the variance for know the which dispersion this park got. So the mean of the first quadrant was 1.2 and its variance after making the operation was 0.02. That means that the dispersion was uniform. What does uniform mean? Uniforms mean that each individual is evenly spaced within the boundaries of the population. It means that it's not too much flowers at the same place and it's not too low population of flowers. It means that there is in the middle of a scale of flowers that it got this part a good thing of flowers. Then I make the second quadrant approximately 40 meters away from the first one. After that, the quadrant and the subquadrant were equal to the first one, and the result give us so similar. Subquadrant 1, 3 flowers, second one 0, third one 1, fourth one 2, fifth one 2, sixth one 0, seventh one 2, eighth one 1, ninth one 2. After making the operations, we got a mean of 1.4 and a variance of 0.4. It means too that the dispersion was uniform because there, I explained before, there is not too much flowers, but there is flowers. You can look them from away. After that, I conclude that the park got the same quantity or the same dispersion because it had the same conditions and because all the things that are around there. For example, the park is pruning every 2 weeks. So maybe most of the plants when the park is pruning they go with the machine or they die. Other reason can be because we are in a season of like winter where it's raining too much, so the water, too many water can kill and give a rust the plants. By other side, it can be the thing that many kids play there and some people play soccer, so they trade the plants, the flowers, so they don't have a big population in the park. But if we look maybe in another part where it's more bigger and the grass is not traded and the people treat him good, the quantity of flowers can be more. And finally, the third part, make an hypothesis where you can make a relation between the first species of Markov recapture method and the second species of the dispersion method. The hypothesis that I made is if the rhinoceros beetle can eat whatever plant nutrient like the one of the yellow flower, then he can survive to another environment different to the one that he is accustomed, like the park of the 127th Street.